Welcome to my work in progress video at the end of week 10. During the past 2 weeks, we have been focusing on developing our prototypes. Here is a documentation of the methods prototyping that we have used and implemented. The first, it's the level management system. Initially, we tested the full gameplay loop after implementing the UI. Looks like the user scanned the environment, then placed the painting, and then the creatures in the app spawn in the scene. The user retrieves the creature and then goes into the badge screen that tells the user which cultural badge they have successfully complete. Then it loops to the next creature in the zodiac and reload the level with the new creature target. We found friction with this loop. The scene switching meant each time we had to get a new scan of the environment and place the painting again. This increased the likelihood of having an AR tracking problem and having the creatures stack on top of each other. The proposed solution that my developer has initiated is instead of loading a new level when we go to the badge screen, we could enable the badge collection as a layer on top of the AR scene. This would allow us to store the AR tracking information while the players interact with the UI. We then need a new way to reset the scene for gameplay with the next creature, including resetting the animation of the creatures, placing a new painting, resetting the timers and UI states. The implemented solution, fairly straightforward. We created a next painting method that adds one to the stored player birth year, then recalculates the zodiac based on that number. Then the level target values are updated with a new creature. There is an event that is invoked, which all creatures listen to, and when called, they reset their own animation states, which is coming off the ground back to their idol. A new painting is spawned at the same location as the old painting, then the old painting is destroyed. This all happens before the start game UI displays. For the next steps of implementation, we think that the current fail state, if the user doesn't find that creature, they have to replay the stage again. This could be changed to the creature escaping and disappearing from the scene entirely. Then the player wouldn't get the badge for that creature. For UI prototypes, we have added the time bar and helper text. The original video prototype in week 4 had an on-screen timer that gave the player some urgency to locate the creature. Upon successfully returning the creature, the player should receive some badges that relate to the values that it represents in folk history. Timer and fail state implementation process was pretty straightforward and repurposes the AR setup progress bar element as a time bar for consistent UI and programming efficiency. A timer is started with a custom method allowing easy manipulation of the timer length when needed. The timer invokes a global timeout event so any necessary classes can subscribe to the single timer and trigger at the same time. While the timer counts down to the painting uses the percentage time left to fade to Y. If the timer runs out, a fail state pop-up UI is triggered. It got away. If you catch the creature, the timer is stopped and reset, and a success pop-up is triggered, which is the badge collection. First, the creature's values had to be mapped. The values or traits, we call them internally, were then assigned to the creature's class directly. When the creature is placed back into the painting, those values are read by the Game Manager class and displayed on the screen. We then need a nice UI to show off all the traits the player had encountered in the forms of badges. The data of the badge UI is persistent in the form of public static dictionary that the key values can be added to. Badges have their own class, which we navigate to the badge screen. The badges look up the corresponding data in the badge collection, if they are collected and how many, and update the UI components to match. For the next iteration, we are still missing a few graphics for the badges, which need to be designed and to complete the interface. And it would be nice to display the badge image along with the trait on the successful capture screen. We have also added background music, all the UI button sound, and the animal sound as placeholder for all 12 animals. So as sound was needed for the game, separated into a few categories as I have explained in the first few weeks of work in progress. It includes interactive sound and ambient sound. The proposed solution is rather than having every class in the game have its own audio sources and controllers, a central method of triggering sound effects was needed. This is because having 12 of each type of object makes the sound difficult to update in response to design challenges. The solution involves a central 2-channel sound manager for non-spatial sounds, which includes interaction sound effects and music and narration. A sound library class was also created to easily tag audio files for other classes to implement them, without needing their own audio clip references. This solution means that other classes such as the painting class, creature class, and game manager can elegantly trigger sounds to play in the central manager with just one line of code. For the individual creature sound effects, it is all kept separate as to spatialize the audio in AR space, so the player can use the pig sounds to locate the pig, etc. Ambient sounds were also kept separate, as these need to constantly loop regardless of the gameplay state. The next step of my work in progress would be replacing all the placeholder UI with the finalized ones that I have been designing. Try a new method of animal spawning to make the randomness better and avoid animals overlapping each other. Have to also create the sound effects and the narration for each animal. And if I have time, I will test out the AR marker for installation version at Magi Expo at the end of the year. Thank you for watching this work in progress video. I'll see you in the next one.